Sir, Taufik sir has joined.
Am I audible, sir?
Yes, sir.
Yeah.
Okay, sir.
Yes,
Sir,
sir.
namaste.
You are
Good
audible.
evening.
Namaste, sir.
Yeah.
Namaste, Jaju, sir.
कैसे हैं?
Namaste,
Yes,
sir. Abhay,
namaste,
sir.
sir. Namaste. Good
Namaste,
evening,
namaste.
sir. Welcome.
भोपाल में ठंड कैसी
Every
है?
time you support us wholeheartedly.
नहीं, भोपाल में तो ठंड है
we
सर,
need-
काफी पड़ रही है।
ठंड है ना?
जी सर, जी सर।
काफी होती है थोड़ा एमपी में। So, निर्वाण सर?
Yes, sir. Can I start, sir?
Yes. You can start.
तो पर उनको वो जब शेयरिंग राइट्स तो फिर इंट्रोडक्शन के बाद में शेयरिंग राइट्स देंगे ना सर को अपन?
Yes, sir.
ओके ठीक, पहले मतलब आप
All the participants, it is a great pleasure that I welcome you to our second technical session of the day that is titled IoT in Healthcare, Smart Devices and System. We were honored to have with us Dr. Mohammad, an estimated assistant professor from Maulana Azad National Institute of Technology, Bhopal, who bring with him a wealth of knowledge and expertise in this exciting and rapidly evolving field. In this session, Dr. Taufik will guide us through the transformative role of IoT in revolutionizing the healthcare, exploring how smart devices and systems are paving the way for a more efficient and connected future in medical technology. Without further ado, let's welcome Dr. Mohammad Taufik sir to enlighten us with his perspective. Over to you, sir.
शेयर नहीं हुआ है सर। निर्वाण सर, आपका वो शेयर तो करो ना सर का स्लाइड।
Sir, I have given the sharing rights to Taufik sir. From his side, he will be share the PPT.
मैं उनके
नहीं,
करने वाला
जो है ना, वो स्लाइड जो है जो
हाँ,
सर
वो शेयर करो
जो बनाया ना डिजिटल बैनर, जस्ट
Okay.
शेयर दैट।
हाँ, वो शेयर करो ना पहले, मैं उनको फिर आई विल ब्रीफ देम ना।
यस।
हाँ, अब इसको मैक्सिमम ये करो,
मेक द स्लाइड शो।
नहीं,
फुल स्क्रीन कर दो।
एंड वो
Please,
जिस पे इंफॉर्मेशन है उनकी
पब्लिक,
वो वाली स्लाइड करो ना।
sir, now it is okay?
हाँ, या ओके।
यस।
Yeah, okay. Yeah. So good evening, dear participants, all faculty members who registered for this ATAL FDP. So this is our today's second session. Okay. So here the resource person is Dr. Mohammad Taufik. Just a minute, I am going to maximize it. Okay. This resource person for this second session is Dr. Mohammad Taufik, Faculty of Mechanical Engineering, Maulana Azad National Institute of Technology, Bhopal. So Dr. Taufik is PhD in mechanical engineering for PDPM, Indian Institute of Information Technology, Design and Manufacturing, Jabalpur. So he is having around 10 plus years of experience. Now he is recently a faculty as assistant professor in mechanical engineering department, Manit Bhopal. His expertise areas are additive manufacturing, CAD/CAM, and rapid prototyping. So obviously, this is the emerging technology being very much used in the 3D printing or additive manufacturing techniques, as well as in the biomedical applications. Dr. Taufik is having 50 plus publications in international journals with 932 citations. So he's having publications in various SCI journals as well as Scopus Index journals. He's having many book chapters and the books also. So he's also the principal investigator of DST SCRB sponsored research grant under Startup Research Grant Program. He is also associated with the development of pallet and the filament from the integrated multi-material co-extruded systems for the improved additive manufacturing processes. He also serves as a senior research fellow under SERB Science and Engineering Research Board, Department of Science and Technology project at Triple ITDM, Jabalpur. So it's an honor for us that Dr. Taufik is with us as a part of resource person in this FDP today. So I welcome you, Taufik sir, and thank you for accepting our invitation. So over to you, sir. Yeah, now you can give the presenter right to Taufik sir. Nirvan sir,
Yes, sir.
we are audible, Taufik sir. Your voice is not coming, sir. Nirvan sir, kindly, I think, unmute Taufik sir.
Now I'm audible, sir?
Yes, now, yes.
Okay, okay. Thank you, sir, for
Yes, sir.
having me here.
Yeah.
And
Yeah.
I would like to give my sincere thanks to all the coordinators, especially Jaju sir and Abhay sir, for inviting me here and give me such a opportunity to talk on the new topic, that is on additive manufacturing and integration of IoT. Now I'm going to give my talk on this particular topic. So could I? Now I can share
yeah,
it.
yeah, you can share it. You share the entire screen, and I think make it maximize so everybody can see only presentation in a full mode.
Can anyone tell me this PPT is visible to
Yes,
you?
yeah, sure.
It is
अब इसको आप
available.
फुल स्क्रीन कर दीजिए, right? Yes.
No, it is visible, sir.
It is
Full
visible,
screen.
but full slideshow is not coming up. Slides are seen.
Okay.
I think so. You have to share the entire screen and then open up your PPT.
Okay, okay, okay.
Yeah,
Share entire screen and then do.
share entire screen and then open.
Entire screen.
Yes.
But in entire screen, oh, okay, okay. Let me.
Yeah. In sharing option, yeah.
Now it is
Yes.
coming, sir.
Yeah, it is
Yes.
coming, sir. It is coming perfectly.
Okay.
Yes.
Yes. Sure.
Okay, okay. So I'm going to give my talk on this topic, additive manufacturing and IoT for healthcare, smart devices and systems. So very good evening to all the participants. Myself is Dr. Mohammad Taufik, and today we are going to see two different things which are very popular nowadays. One is the additive manufacturing and other one is the IoT, Internet of Things. So we will start with the first additive manufacturing, then we will see IoT, and then we will go for the integration of both. Okay, so how we can benefited from this technology through this particular lecture I am going to discuss. So first of all, I am going to discuss about this additive manufacturing. So you can observe from this particular slides that additive manufacturing, which is also known as the layered manufacturing, in which we are going to add material layer by layer. So unlike the conventional manufacturing processes, where we are going to remove material to form or build any part. Here we are going to add material to build any part. So from this animation you can easily observe it also. And this technology is also known as 3D printing, rapid prototyping, as well as digital manufacturing, and similar names are there. So this particular technology we are utilizing the with different type of materials like polymers, metals, ceramic. So because of this type of different type of material we can utilize with this particular technology, we can utilize this particular additive manufacturing processes with the different applications. So if you are going to see this particular additive manufacturing process, you people can observe this particular additive manufacturing process is nowadays very popular among different communities. Why this is happening? Because if you remember that at the time of COVID-19, also people have utilized this particular technology in pandemic management. So you can see here I have taken some references. From this reference you can easily observe that frontline workers are utilizing here this additive manufacturing based build parts which has been utilized for making their face mask. In other example, here in Manit Bhopal, we have also printed some part of the ventilator that time with the help of additive manufacturing process, because it is very difficult to go outside at the COVID-19 time. So some part which are very critical we have printed through this, and we have successfully developed one ventilator at the time of COVID-19. Other thing you can also see here why this particular technology is rapidly accepted by different communities. For this I have added one small video here, and then in this video I am going to show you a very brief introduction of additive manufacturing in a very different type of application. You can see from this project title, the title of the project is Development of 3D printed arm or elbow operated water tap handles to make the water tap handles safer in a common washroom. So to explain this, I have added one short video that I am going to play now. So you can see here, as you learn about this process, this is the additive manufacturing process. In we are going to convert our thoughts into reality. Idea we can change into reality with very less time. So for example, here what we are seeing on the screen now, this is the CAD model. If you have any idea, you can convert your idea in a CAD model with the help of any geometrical modeling software which are available in the market like Creo, SolidWorks, Unigraphics, CATIA, and similar other geometrical modeling software. And then you can transfer your CAD data to the machine where with the help of G and M code your part is going to print. The same CAD model you can observe here on the screen which is printing. After printing, I have some sort of object, and with the help of some post processing at the time of COVID-19 we have installed this on the water tap. So instead of opening it from hand, we are going to operate it from arm or elbow. So as you know that the common washrooms are very prone towards the rapidly infections. So we are not going to contact at that time our water tap handles with the help of our hand, we are utilizing arm or elbow, so it will help to prevent this infection. Okay, so this type of idea, if you have, quickly you can convert into the reality. So this is the one of the benefit of this type of technology. You need not to go for the conventional method of manufacturing. If you are going to see the geometry of this particular printed object, you can easily observe that if you are going to print this to fabricate this particular technology with the help of any other processes like casting, then you required mold, then you required pattern. So first you required pattern, and then you are need to create a mold, and in the mold you need to pour the molten metal. Then after you have to perform some post processing, then you will get the final parts. Sorry. So similarly, if you are going for machining, also you required from some sort of billet, and then in that billet you are going to remove the excess material. Means multiple machines sometime or multiple processing you required, but here for the additive manufacturing, one tabletop machine you can use to print this particular thing. That's why this particular additive manufacturing process is very popular among different application sector, whether it is a conventional or non-conventional application sectors like this pandemic management at the time of COVID-19. So you people also have observed that face mask, and this is the one of the example at the time of COVID-19 that we have heard about that ventilator shortage. So some researchers have printed ventilator splitter at the time of COVID-19. With the help of this ventilator splitter, multiple patients they have accommodated with the same ventilator, so they can save life of different patients. So here, if you are going to see this additive manufacturing process, we can utilize in a different situation that has been not explored. In that situation also we can utilize this process. So why healthcare now? Why healthcare needs smart care? Now this is the question. This question arises because the challenges arises from the COVID-19. If you are going to see, the COVID-19 pandemic has underscored the urgent need for smart care in the healthcare system worldwide. Faced with the unprecedented surge in the patients' numbers during the pandemic, hospitals and clients struggled to manage resources effectively. That's why people are look forward for the other non-traditional method to care. And for that, if you are going to work with the smart manufacturing technique like additive manufacturing with the IoT, then we are going to utilize it in a very personalized manner. We can treat the people in a more effective and less time manner. So we can go for the very customized patient care units. We can collect the real time data and analyze different type of data, patient data, and then we can take a decision, and we can create suitable and sustainable care for the patient. So these are the needs that we can observe easily. So if we are going to talk about the smart technology for healthcare management, we are certainly moving towards two three things. One is the additive manufacturing, another one is the internet of thing. With the help of the machine learning or augmented or virtual reality, also we can utilize this thing in an integration and or in a one by one or coupled manner. So before understanding all these things, one should have the knowledge of basic additive manufacturing process, then we can move for its applications. Okay, So it is very important to understand which type of additive manufacturing process we have and how these manufacturing processes are helpful in making different type of. So we have given a very short type of classification for additive manufacturing process here. If I'm going to utilize this particular classification, this classification includes liquid based, powder based and solid based materials, and based on the material being utilized, we can classify a process as a stereolithography. If we are going to utilize liquid as a process, then we can say this is the stereolithography process. And if we are going to utilize powder as a input material, then we can classify as a selective laser sintering process. And the same time, if material input in the form of solid means wire form, then we can classify that particular process as a fluid deposition modeling. These three are a basic classification for additive manufacturing processes. Apart from it, we have different classification also, which is based on the ISO, and generally that ISO classification based on the energy uses, means from lower to higher energy uses we can classify our process. Okay, so quickly we are going to see these processes, that after that we can understand how we can utilize this process for making different application in healthcare. So first application I'm going to show you, one is the which is the fluid deposition modeling technology. And as I know you, as I told you, that this is the solid based additive manufacturing process. So here we are going to utilize material in the form of wire. So I have one small video for it. Through this video we are going to understand this process. So through this animation, I hope you people will understand it in a more better way. Please have a look. So anyone please tell me the you are getting wise or not? Audio is coming or not? Anyone please tell me audio is coming or not?
Sir, the video audio is not audible.
Okay, okay. So I am going to explain it. Again, I am going to restart this video as you are saying that audio is not coming. So see here, first process is fluid deposition modeling process, where material in the form of wire we are going to utilize. So see here, this fluid deposition modeling process, the name is given by the Stratasys company. So now you can see here we have a nozzle. Through nozzle, the semi-molten polymeric material is extruding, and this extruded material is going to utilize to make any three-dimensional complex part. So you can observe here also, nozzle is precisely providing the material. So the first step is the slicing. Once we have the slice the data, then we can transfer that data to this machine. Here we have two spools. One is for the support material and other one is for the model material. So see here, this two spool we are going to utilize, and this wire is going to fade through the feeding mechanism, to the nozzle, and here in this nozzle we have a different assembly. One is roller, which is going to pass the wire through the molten nozzle, and then material is going to extrude layer by layer. You can see here, and we have two type of material. One is the black in color and other is white in color. So you can observe, if we have overhang, then we required support material which in white in color. Once we have our part printed, then we are going to take it out and then go for the post processing, where unnecessary material we are going to remove or clean, okay, through the simply mechanical way, or we can utilize the solution. See here. And after that post processing, the quality of part is more precise, or say more, the surface quality of part is going to improve, that can be utilized as the end product. So this is the example of fluid deposition modeling process. Okay. Similarly, I have other video which is selective laser centering. Okay, which is for the selective laser centering process. So here in the selective laser centering process, we have material in the form of powder. So here, instead of heated nozzle, here in case of selective laser centering machine, we have laser, okay, high power laser, for example CO2 laser. That CO2 laser is going to sinter the powder particles. So you can observe also from this video, and as we are utilizing powder as a material here, so different type of sometime composite also we can print with the help of this particular technology. You can see here drones and different application in biomedical healthcare sectors. So it also start with the slicing of the CAD data. Whatever CAD data you have, or particular medical device data in the form of CAD, you are going to pass to the machine, where machine is going to read layer by layer slice information, and for each slice we are going to sinter the powder particle one by one. Means each time we are going to recode the powder particle, unsintered powder particle over the sintered powder particle, and this process is repeated until we are going to complete our part or slice data. Once we have reached up to maximum slice data height, our sintering process will stop, and then we are going to take it out our part from the build chamber. So we can see here from this animation also, the center part is the build chamber part, from where after sintering we are going to take it out, and then we are going for the post processing. We have some brush, okay, and then vacuum cleaner, through which we are going to clean it, and then this cleaned part we can further utilize for our different application. For example, if you are going to take the biomedical based polymer or metals, then we are going to utilize that particular part in an implant. Similarly, in a third case, if you are going to see, third case is based on the material which are in liquid state. If the material which are going to utilize in a liquid state and it is an input material for additive manufacturing, then this type of material is going to be utilized by stereolithography operators. So the third example is the stereolithography operators. Here in stereolithographic operators, we are going to utilize material in the form of liquid, and this liquid form material we are going to cure with the help of again laser, but this time this laser is working based on the UV light. So UV light laser we are going to utilize. Whenever this UV light laser is going to utilize for the curing of photosensitive regions, This photosensitive region is going to cure whenever light is going to strike on it, and then after curing we will take it from the tank, and then we will utilize this particular part for further post processing. Like if the part is having some sort of internal cavity or other thing, then we can go for the extra heating in oven. So here you can see, here we have the tank. In this tank we have the photosensitive regions in the form of liquid, and this is the laser system, UV light source, and a small energy laser source. This is the UV light source, and through this we are going to cure the layer, each layer one after another. See here, you can see the animation, and after curing each layer one after another, we are going to get the final part. And this type of part also we can utilize for a different application sector, from healthcare to automobile to uh, uh, aeroplane part. In different field we can utilize, in computers, in different sector we can utilize this type of part. So you can see here, this is a part also required post processing in term of extra heating. And after extra heating, the part you can see is more rigid in nature, and then after further post processing, means spray painting and other thing, you can utilize in a different application sector. Like this is our mouse, daily uses mouse, we can print with the this type of materials. So if you are going to see all these processes having some sort of similar steps that I'm going to tell you. So see, if one is observe this particular process in very detailed manner, they can observe that, sorry, they can observe that first step is, this is the first step. This first step is the CAD model creation. Okay, so first step is the CAD model creation, and then once you have the CAD model, then you can go for the STL format translation. Means directly we are not going to slice our part in additive manufacturing. First of all, we should have a CAD model. Once we have the CAD model, then what we can do, then we will go for the changing this CAD model to the STL file format. This STL file format is known as the standard tessellation language, or also known as the stereolithography file format. So what is happening here? Here we are going to convert our surface model in a piecewise triangular approximation model. Whatever surface we have, we are going to first convert into the triangular pieces, and through which we are going to make the approximation of the surface. And during changing from one file format, CAD native file format, to the STL file format, we have always some sort of error associated with this type of transformation from one file format to another file format. To prevent it, what we need to do, we need to check whether our STL is properly built or not. So there are different type of error, means facing, we have the missing facet issues, sometime overlapping triangles we have. So this type of error are very problematic, because whenever we are going for slicing, let us assume we are going for the slicing, and the same time what is happening, one of the triangular approximation is missing from the whole STL model, means we have a missing facet problem. So what will happen, our contour is not going to closely created, because there is a gap. Due to this, we are not able to create the proper tool path, and this is the problem we can encounter if we are not going to make our STL file format formation in a proper manner. So that's why the third step you can see here, verification of STL, where with the help of some software or some program, we can check whether our STL is watertight or not. Then once we have find out our STL is properly built, then we are going to set the process parameter. See, process parameter setting is a very crucial aspect of additive manufacturing, because whenever we are going to set the process parameter, it can affect different type of quality of build part that we are going to see in our next slides. Once we have the parameter setting means slice thickness, what will be the slice thickness, what will be the orientation of the object, for example. These are the very crucial parameters in additive manufacturing. Once we have set the parameter, then we can go for the slicing. Slicing is a very essential step, because after slicing we need to go for the tool part definition. So up to the slicing and then tool part definition, we have different steps. For example, CAD model generation, STL file translation, verification of STL, parameter setting, slicing, and some cases we require the support generation, and the next step is the tool part definition. So before tool part definition, most of the steps in different additive manufacturing processes are same, almost same. And here in tool part definition, if you are going to remember in our previous slide, we have animation for tool path, and in some cases we have utilized heated nozzle. Based on that, we are going to write down the tool path. In some cases we are utilizing laser source. Based on that, if anyone is asking to make a tool path, you are going to make your tool path. So based on the different type of energy sources, okay, like laser or heating nozzle, we are going to create our tool path. For example, the nozzle diameter is significantly large with respect to the laser diameter. So whenever we have the laser or nozzle, in both cases tool part definition in a different way. So means from tool part definition onwards, we have very specific process. Based on that, we are going to provide or set or follow the different uh, procedures. For example, if it is a solid based additive manufacturing process, tool part definition is based on the heated nozzle, and then we are going to utilize fluid deposition modeling process for additive fabrication, and then in part remover or cleaning, we are going to remove our part with the breakaway or soluble solution type of post processing technique. If we are going to utilize the laser dia for tool part definition, then in additive fabrication we are going to utilize selective laser centering or stereolithography apparatus for additive fabrication. And based on the process we are utilizing, for example, if it is a selective laser centering, we need to go for the removal of powder particle in the post processing with the help of brushes and vacuum cleaner. Or else if we are going to utilize stereolithography apparatus process, then we are going to utilize other post processing technique where we can require oven and other things as a final step. So these are the things that are associated with the different additive manufacturing process. So means from solid model generation by CAD up to slicing, most of the steps are common, and from tool part definition to the part removal or cleaning, it is a very process specific steps. Okay, then few issues always associated with the additive manufacturing processes. For example, staircase effect. Okay, whenever we are going to make our part layer by layer in a layer by layer manner, so it will always create a stair type structures. You can also see from the figure in the right side, top right side of the slide, that we have this type of structure, and this particular effect is known as the staircase effect. Okay, and where the two stairs are meeting, and if we are going to make perpendicular on the actual surface, then this height is known as the cusp height. And due to this approximation, layer by layer approximation, always we have loss of information, which is known as the volumetric error. If we are going to see in xyz direction, that example you can easily observe at the lower left side uh, of the this particular PPT. And the same time, sometime if we are going to print your part, so you are going to get some of the layer is outside of the required geometry, some of the layer are inside of the required geometry. That you can see at the lower right side. And the same time, sometime if you are going to print the part, all the layers are completely outside, and in some condition all the layer are completely inside. So this different type of additive part we can create. Okay, and if you are going for some healthcare related printing, for example, if you are going for some prosthetic fabrication, and we have in this medical device, if we have the higher value of surface roughness, okay, so what it will going to do, it will provide a uncomfort to the particular uh, patient whenever he is going to wear that particular prosthetic. Due to the direct contact with the skin, it it can provide a wear, and then provide the uneven pressure. That are the one of the most significant challenges. So how we can reduce it? This is the problem which is associated with the additive manufacturing and other conventional prosthetic also. If any person is going to utilize prosthetic, for example, and that prosthetic it provides uncomfort due to the uneven pressure distribution through this particular prosthetic, or due to the rough surface, there is some sort of itching and all this thing, then how we can improve it? This is the problem. That's why we require the internet of thing, that we are going to understand. First we are understanding the problem, and to reduce this problem we are going to utilize the IoT means. So are the basic problem. So what are the problem? We are not getting the exact replica of the part, and we have the volumetric error, okay, due to the staircase effects. And sometimes we are getting parts completely inside, outside, or are mixed type, and this is providing very uncomfort to the patient. Okay, so some sort of guidelines is here that we need to think whenever we are going to print any medical device or system with this additive manufacturing technique. First is that if we have required any part with the good surface quality, so what we can do, we can uh, concentrate on the very first step of additive manufacturing, where we are utilizing STL. So what we can do here, first of all, we are going to take the CAD geometry, and then we can go for the fine resolution of that particular STL. Okay, if you are going to take a very large triangles, and then you are going to take any part which is very patient specific for other application, so it will create uncomfort. Okay, so what we can do, we can make a part with the smaller approximation of STL files. Okay, so piecewise triangular approximation we can take smaller, and then we can go for the printing. Okay, then second, how we can control the different issues. We have different type of softwares. For example, there is a online software Cura, Magix, Mimix. Mimix is basically a dedicated software for the medical application where CT images we are going to read, and with the Mimix we can separate the bone and the soft tissue, and then we can analyze it, and based on the patient specific data, each 2D layers we can print, and then study we can utilize in training and testing, and then we can go for the further improvement. So how we can utilize it, we can also see in our next slide. Then the third thing is how we are going to improve the process quality of 3D printed devices. So here, if you are going to print any device in a two different direction, for example, I am going to take one small example here. For example, one dog bone specimen I have taken here, for example, and for example, we are going to print one sort of pad, okay, that we are going to utilize to reduce the friction between the prosthetic and human hand. Okay, for that, so what we want a very good strength pad we want to produce with a good surface quality. So first, how we are going to print it so it can provide a very good strength. So for example, I have taken two cases. In case 1A, the dog board specimen I have here, and I am going to print it in a vertical direction, means like this along the length. And second one, I am going to print the dog bone specimen perpendicular the length. Okay, in both cases we are going to provide our force which is the along the length of the dog bone specimen. So I would like to ask from audience, in which case you are thinking that this dog bone specimen is going to break early, in case A or in case B? Anyone? Anyone? Please tell me what you think. In case A or in case B, in which case we are going to see the breakage first? So of course, if you are going to see in case B, it is going to break easily because layer is easily going to delaminate. Okay, and in case 1, because the layer is along the length of the specimen, it will provide more density and more resistance toward the fracture. Similarly, if you are going to see second case, here we have two different inclination of the object. If you are going to see, one is very stiff in left side, and in other side, in right side, we have the very shallow surface. So you can see if the layer thickness x in both cases are same, due to the inclination, this y is actually very high in case of the right side specimen, because it is providing more staircase effect. So you can see here, if you are going to change the orientation, you can control the surface quality or surface roughness. So, so here from that you can observe if you are going to build any uh, prosthetics or any sort of medical devices where comfort is very important to the patient, that time we will always concentrate on the surface quality. If surface roughness is very high during utilization of that particular prosthetic, our patient is going to uh, feel uncomfort. So to reduce it, we have to take care of these things. Then then you can see here the different slicing strategy we have also. If you are going to see this slide, there are three blocks which is similar in nature, but if we are going to slice in a three different way. For example, in first case, if you are going to slice from bottom to up, then we are going to get the part which is undersize at the bottom and oversize at the top. And similarly, if you are going to see the second slicing procedure through this animation, if you are going to make our part sliced with the top down slicing procedure, we can observe our upper portion is showing deviation in form of undersized part fabrication, and lower one is showing the oversized part fabrication. And third one is the combined slicing process. If we are going to utilize half of the slice from both bottom up and top down slicing procedure, then we can get either undersized completely or completely oversized part fabrication. Okay, so in this way you can control the shape of the particular component. For example, if you are going to create some sort of pattern or mold, okay, in this condition you can take the lower undersized parts, okay, as a pattern, and through this pattern, if you are going to create the mold after solidification, it is possible that it can acquire the possible size. And the second one, if you are the green one, if you are going to take, so first of all you need to remove the extra material, then you can utilize as a final part. So these are the example how we can control the dimensions or surface quality of the printed specimen, which can further utilize in a medical applications. The same time, there are different parts which is having support requirement. For example, if we are going to see different object which are having that particular inclination or overhanging surfaces that require support, so always we need to think about the process. If you are going to work with the, for example, fused filament fabrication or fused deposition modeling process, at that time you need to take care at which inclination the support are going to generated. For example, if we are going to take our ear example, and if we are going to see the cadaver bone, so there are a small bones are there, and sometime it is very difficult to take support material from the printed cadaver bone replica through the additive manufacturing process. So that time it is very difficult to remove the support material. Okay, so we need to take care of support also. So one rule of thumb is that if the inclination is less than 45 degree, so it required in some cases no support, and if the inclination is more than 60 degree, it will require support. So we can check with the help of different software, for example Magix or Cura software. Then if we are going to utilize all these steps in a proper manner, then we have the different application sectors where we can utilize this additive manufacturing processes. So if you are going to talk about this additive manufacturing process, it starts with the application in prototyping and ends with the direct part fabrication. So in late 80s, this process started with the purpose of prototyping. Nowadays, with the help of development of different materials which can be applicable in additive manufacturing, this process has been utilized in different application sectors. For example, this slide you can observe that we have started with the plastic. Now with the advancement in the design and fabrication of additive manufacturing machines, we are now able to print the glass, tissue, metals and different type of materials, which is ranging from the plastic to ceramics, then soft tissue. We can print the art and many more things with the help of the advancement. So we are going to see this historical perspective also. So if you are going to see here in the prototype development, you can utilize this process, which is starting phase of this particular additive manufacturing process. You can see this is the water splash cross section of 3D printed model. Then this is the space frame construction. You can go to create the truss and then study. Then visualization of the flow pattern. You have some sort of element where with the help of 3D printing process we can go for the color 3D printed model and then visualize the all the result of the ANSYS, the FEM analysis, and easily observe where the stresses are high or low. The similar type of color images you can convert into the STL and then print it according to their color. Also with the help of this process we can go for the different type of assembly processes. Okay, in education purpose people are also printing the bicycles. This is particular example I have taken from the University of Italy. And then other process is rapid tooling. If you are going to utilize this particular process as a pattern making tool, then this process can be termed as a rapid tooling. So here in rapid tooling we have additively manufactured pattern. Through that pattern we can going to create the mold. See, like the conventional casting process where we have the pattern from the wood, metal, ceramic, plaster of Paris or other things that we are going to create with the conventional manufacturing process. Here in the rapid tooling process, what we are doing, we are replacing the conventional manufacturing processes of pattern making and utilizing here the additive manufacturing process for making the pattern. Okay, so you can see here for the conventional uh, casting process, you can see here first of all, if right side, top right side, if you are going to see, we have the CAD model. With this CAD model we are going to utilize wax as a material, and with the help of this wax we can print our part, 3D printed part. And then like the loss wax casting process or investment casting process, the similar process also we can utilize here. We can go in a third step, the ceramic cell coating. After the coating, like the conventional processes, what we are doing in the conventional casting process or investment casting process, we have the wax pattern which is not fabricated through the 3D printing process, but we can print it in a with the help of 3D printing nowadays. And then the other processes or steps are same. Once we have the 3D printing wax pattern, we can go for the cell coating, then drying, then dewaxing, and then we are going to pour the particular material there, and then we are going to crack the cell and then we get the final part. We can see the final part at the lower left, lower right side of the this particular PPT. Okay, so like this we can utilize in a very precise part making also. Okay, then other example in a direct part manufacturing in a healthcare. Now you can see here, this is the orthosis, ankle foot orthosis we can see here. Then scaffold tissue engineering, we can create a different type of scaffold where we can grow our tissues. Then we can utilize in an implant, mandibular implant. People are utilizing this particular technique in healthcare in making some sort of surgical guides. And the same time nowadays, uh, we are also utilizing in personalized medicine. So what we are going to do here with the help of additive manufacturing, what we are actually doing with the help of additive manufacturing nowadays, we are printing the personalized medicine. For example, multiple medicines in one tablet we can print with the help of additive manufacturing by controlling it active pharmaceutical ingredients. Okay, and then we are going to print it. Then these are the basic of the additive manufacturing process. So what we have seen, uh, additive manufacturing, we why this particular additive manufacturing is so popular among in different application sector. Then we have seen what is the need of smart or IoT based additive manufacturing process. That need arises at the time of COVID-19, what we have seen due to the shortage of our ineffective communication between the client and doctors. Then we have seen how we can utilize this particular additive manufacturing process in uh, with the help of proper selection of process parameter. To understand it, first we have seen the different additive manufacturing processes like solid based, liquid based, and powder based processes. uh, in solid based process we have the fused deposition modeling process, selective fused filament fabrication process. In powder based process we have seen the selective laser sintering process. In liquid based process we have seen the stereolithography apparatus. And then we have seen all the steps which start with the CAD model, then STL formulation, then error removing, then slicing. We have seen slicing, then we have seen support generation. After support generation, we have talked about the tool part definition, which is very specific to particular additive manufacturing process. Then we have seen the additive fabrication techniques, then post processing. These are the steps and how additive manufacturing build parts are affected by different issues. We have also seen like the staircase effect. If the poor surface quality is there, then it will uh, provide uncomfort to the patient. We have seen, and there are different sort of issues: poor part surface quality, and then shape deviation, volumetric error we have seen in additive manufacturing section. Then we have seen how we can control it. From the STL, we can take a very small or finer STL approximation. Then we have seen uh, different uh, softwares that we can utilize like the magics mimics. Then we have seen the process parameter selection. If you are going to select process parameter correctly, for example, if you are going to take right orientation, it will improve the surface quality. And then we have seen different application which can classify in a three-way: prototyping, rapid tooling, and direct part manufacturing. Now we are dealing with this direct part manufacturing technique with the help of additive manufacturing. And to further improve this particular thing, that what we have seen, this particular process started with prototyping. Nowadays we are utilizing direct part or production grade part. Now how we can further improve this particular process? So what we can do, we can going to integrate this thing with the internet of things. So basically the internet of things refers to a network or physical object or things that are embedded with the sensors, software and other technologies to connect and exchange data with other devices and system over the internet. So this object can range from everyday household item to the industrial equipment, making them smart by enabling them to collect, share, act on information. So basically what we are trying to tell here, see here with the help of one image, we are going to understand it. See, in a middle we have the cloud unit where data is going to store, and then we have the IoT gateway or framework which is connected to the cloud unit, and this IoT gateway or framework further connected with the sensor unit which is shown at the left side of the PPT. So different condition these are connected, and through this IoT gateway or framework we have the wireless communication to the client unit where doctor or other persons are there. They can take your report automatically, and then accordingly they can provide the prescription, and based on that your uh, healthcare support could be improved. So here healthcare internet of things, HIoT. If we are going to talk about HIoT services, there are the different element: ambient, assisted living, mobile IoT. We have seen wearable devices. We are utilizing community-based healthcare services, cognitive computing, advanced drugs reduction, child health information, blockchain. All are interconnected with the healthcare internet of thing. So if you are going to see the integration of additive manufacturing and internet of thing, so here in additive manufacturing IoT facility, rapid prototyping and production of essential medical devices and supply chain disruption, the IoT's real-time data-driven capabilities further optimize AM workflow, ensuring that production adapts to fluctuating demands below during the health emergencies. So here this can be easily understood with the help of this flow diagram. So what we have seen in the earlier slide, that our additive manufacturing start with CAD design. So the same is written here. The design the model using the CAD software, means any geometrical modeling software or any other 3D printing software also you can utilize. Okay, for example, uh, Magics or any CAD software, for example, uh, AutoCAD, Creo, SolidWorks, that you can utilize. And then check the feasibility of the design, means we need to check whether it can be print or not. Okay, what are the basic features of our particular design? It is possible that particular feature we can print or not with our additive manufacturing machine. These are the things that we need to check the feasibility. Whatever the minimum layer thickness, we can go with that particular part. Then choose the right process and right material. For example, we need to go for the implant, then we can select a titanium material. And then right process, which process we cannot go with the simple uh, powder based, any powder based process or any uh, uh, solid based process. We can go with the high powered metal additive manufacturing process. Okay, which is going to justify all the requirement of medical grade material that can process easily. So we can go for the, for example, titanium. We can go with the metal 3D printer. And then if you are going to see that the left side, what it is saying, IoT enable MRI machines. can store the high resolution image which can be assessed by the doctor to print the 3D model of the problem. So what we can do, we all heard about the MRI machine. So through MRI machine, we are going to take the CT images, high resolution images, which can be assessed by the doctor, okay, which is far away from the particular MRI center. Simply they can send that particular data to doctor, and doctor further check, and they can send to the IoT enabled 3D printer where it can easily print that particular part. Similar way, embedded the sensor in the printed model. Also, we can embedded the printer sensors in the printed model and connect it to the IoT to track functionality by analyzing the data. For example, we have some sort of prosthetic. What we can do, we are going to embed that particular sensors in the prosthetic, for example. And in that particular prosthetic, for example, if anyone is going to do some work, it is experiencing some sort of pressures, uneven pressure, and whatever the force exerting, all data you can store with the help of sensor. And further, this stored data you can analyze. Based on the analyzation of the data, you can change your design of the prosthetic. For example, initially we have some sort of prosthetic, and then based on the high pressure point, we can change that pressure point, or we can provide some sort of cushion there, so it can improve the comfort of the particular patient. Similarly, customized surgical tool we can produce with the 3D printed, which can be used during the robot assisted surgeries to obtain the greater precision. So all these things we are thinking with the help of IoT, Internet of Things. Okay, so it is very important to integrate this Internet of Thing with the additive manufacturing. So IoT based smart devices easily we can produce. We can see the incorporation of the sensor, what we have just discussed. The incorporation of the sensor in implant can help to detect the infection also. So all these things we can do. These are the some IoT based devices we can think about, and then further we can utilize in with the help of additive manufacturing processes. So here I have taken one case study to show you. This is the real case study where what the author have done. They have first taken the limb malformation, and then they have taken the 3D scanning of particular hand, and then what they have done, they have created some sort of mold, and with the in that particular mold they have integrated the sensors. So whenever that particular human subject is going to press or do some work, whatever the forces he is going to experience, it is going to record through that particular sensor, and which is possible only with the 3D printing, that we can conformal electrode we can print with the 3D printers. So here you can see the broader view of it also, this IoT based device. Here if you are going to see in the right side of PPT, the last right side, third one, so you can observe that this conformal electrode are printed. This is printed with the help of 3D printer, which are conductive in nature, and these are connected with the sensors. So with the help of sensor, data is going to record, and whenever that particular patient is going to apply the force, based on that we are going to improve the design, because this type of uh, abnormality is generally encountered with the children. So children are not able to tell where what are the uncomfortabilities along with this type of prosthetic. So what we can do in such situations, we can utilize the IoT. Through IoT we can understand because if the children is, for example, very less in age, they are not going to explain in a better way. So with the help of sensor we can easily understand, so we can change that particular device, okay, and that particular prosthetic, and we can improve the comfort of the children or any patient. So this is the way we can utilize IoT. So you can see here very effectively author have utilized that particular IoT based information. Okay. The second one, if this is the second one, the second case study here, the smartphone control 3D printed hand prosthetic also printed with the help of 3D printer, where the author have utilized the Bluetooth technology. What they have done, they have printed the hand prosthetic, and then there is a MIT app, okay, through which they have controlled the prosthetic hand. Uh, okay, so in this way also you can control the prosthetic hand. So with the help of IoT or Bluetooth technology, the people are taking it in a very efficient manner to improve the user experience. We can, what we can do with the phone, we are going to give the voice command, and based on that voice command we are going to change the movement of particular prosthetics. That this is also a very unique way to control the prosthetic, okay, hand. So there are some sort of challenges also. The limited machine to cloud communication, no universal communication standard for the different 3D printer and sensor integration. AM processes are complex and sensitive to the specific print setting. If print setting is not correct, then the final quality of the part can be deteriorated, or it cannot be usable. Equal access of technologies across healthcare sectors. There are some sort of regularities and the standardization challenges. Some sort of rules, regulations are there in the healthcare sections. Okay, so these things are there. These are the challenges. So now we are going to see the conclusion of this particular talk. The convergence of the additive manufacturing and IoT has the potential to transform rigid healthcare into the flexible healthcare. Means we can flexibly utilize both of things to improve the patient care. Together, this technology enable a more resilient, decentralized healthcare system capable of addressing supply shortage, enhancing the patient care, and optimizing resource allocation. The third point is the integration of AM and IoT hold the promise of improving healthcare delivery in both crisis and non-crisis situation. What we have seen at the time of pandemic such as COVID-19, we have seen that additive manufacturing utilized in a very effective way in that case of ventilator splitter or else other applications. Thus, this synergy offers personalized cost effective healthcare solution. So for the particular healthcare solution, very uh, 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 customized prosthetic, what we have seen anyone can build, which is a cost effective low cost prosthetic also we can build, and the same time we can go for the customized medicine printing and other things. So these are the main element of this integration. So what we can see, these are the main conclusion of this talk. So these are the references I have taken. Now thank you. So the last 10 minutes we have left for the question answer session from my side. It is over. Now over to coordinator.
Mhm.
Thank you.
Thank you, Dr. Taufik sir. Yeah, we're having some questions in the message panel.
Okay,
Okay,
okay.
E
Please tell me,
Bhaskar.
sir.
Yeah, yeah. E Bhaskar, sir. Just a minute. E Bhaskar is asking that, sir, how can we analyze the mechanical properties of a product that is made by additive manufacturing
Okay, okay.
methods or
So,
any other software is available?
so whenever we are going for the mechanical properties, there are two way. One is the destructive and non-destructive testing. So in both way, you can check the property of additively manufactured part. For example, if you don't want to go for the destructive testing, you can go for the scanning of the object and the visualize, characterize the things, and then check the porosity and all other aspect. If you want to go for the destructive testing, there is the tensile or compressive testing and similar testing, wear and all this testing based on the special standards. You can go and then check. So whenever we are going for any medical application, for example, any implant, before giving it to the doctor, we need to check whether it is replicating the actual strength like our bone or not. So we can go for the mechanical testing like the strength and tensile or compressive strength.
Yeah, there
Hope
is,
the answer
yeah,
of the question.
might be satisfied. Yeah. So there is another question from Murthy Kumar. Yeah, Murthy Kumar. Then Sudhir Kini. Okay, can we fabricate magnesium using LPBF? What are the challenges for that?
So nowadays people are going for the magnesium because it is a very emerging material. With the help of additive manufacturing, there is some sort of challenges and very specified machines are coming. With help of that machine only we can go for the printing. Otherwise, all the machine we cannot utilize the magnesium for the printing.
Yeah.
Sir, one question from Anil Vanalkar, sir.
Anil, yeah. Dr.
Whether
A.V.
3D
Vanalkar
printing,
from KDK
yeah,
College of Engineering. Yeah, we also know.
whether 3D
So,
printing is
yeah,
viable for mass production.
mass production.
So see sir, there are something whenever we are going to talk about the additive manufacturing, okay, this technology having the capabilities that it can go for the customized printing or different type of part printing. So if the same 3D printing, if we are going to utilize for printing on one sort of component, so it will not give more benefit. We can go, but it will not benefit more, because if you are going to print the same thing that can be utilized for the multiple thing, then you are going to restrict it. In the same way, people are not preferring it, but nowadays there is some sort of thinking are also coming that we can go for the mass production. And if we are going for the mass production with this type of machine, for example 3D printing or CNC machine, then this type of printing or machining or manufacturing is come under the category of smart manufacturing. So smart manufacturing tell us that this type of machine also we can utilize for the mass manufacturing. But till now, these things have not been materialized yet. It is up to a theory level. Basically, in short, we are not utilizing this type of thing. For batch production, we are utilizing 3D printer,
Yeah.
basically.
Okay. There is one another message from Muthu Kumar V. What natural fibers are utilized in 3D printed polymer composite for specific human body in biomedical application?
So, sir, different type of natural fibers are people are utilizing. We can make it very specific because we have different sort of requirement. Okay, so we cannot tell us any particular name. It is very patient specific. Okay.
Dr. Pankaj Wankhede is asking how to improve the accuracy in manufacturing of polymer gears.
See, whenever we are going to talk about the accuracy of, can he tell me for which process he is asking? If he is there, please unmute. Please tell me. Basically, for which process?
Dr. Nilesh Nirwan, sir, kindly unmute that V.
पंकज वानखेड़े ना, पंकज
Pankaj
वानखेड़े को
Wankhede.
करना है सर.
Pankaj
Just a
Wankhede,
minute. Just a
उनको
minute.
unmute कीजिए.
हाँ.
For which process he is asking?
Yes.
So
Now
it is
Pankaj Wankhede can unmute and talk.
Yeah, Dr. Pankaj Wankhede, sir, you can unmute or you can type what the sir is asking. For which
Ac-
materials?
Actually,
Okay.
sir, we thought to procure the gears by using the PLA and ABS for the
okay.
different
I got the
application.
problem. So
Yes,
we are going to utilize this fluid deposition modeling, are also
yes,
known as
yes,
the
FDM only, sir, FDM only.
FDM. So which
Uh-huh.
machine you have? Statisys machine, sir?
No, sir, Statsys, we don't have this much costly machine. We have only this Ender
Normal machines.
Creality.
Okay. So this machine
Yes,
we can't name it as FDM. So fluid filament fabrication process we are telling it, because the
yes,
FDM
yes,
is
yes.
a name associated with the copyright with the statistics. So
Statistics.
whenever we are going to utilize this type of machine for higher accuracy, some important thing you need to see. My suggestions are that you have to take care of orientation, sir.
Okay.
Okay, the first
Hmm.
main criteria is orientation. If you are going to orient it along the
Hmm.
plane, okay, then you are going to get the more accurate part.
Okay.
Otherwise, if you are going to make it like this vertical, always there is some sort of support requirement, then it is going to affect the accuracy. So always print like that horizontally, sir. Then
Okay.
we will
Okay.
get the maximum accuracy in your printed part. Otherwise, we will not get. The orientation and
Okay.
main factor, sir. Hope the answer of the question.
Okay, sir. Okay. Thank you.
Okay, these were some questions for the audience, and I think Dr. Taufik has given the answers to all the questions, and you will get the answers. So I think we will conclude the session.
Yes.
Yeah. On behalf of Center of Excellence 3D Printing and as a co-coordinator and Dr. Jaju sir and me, we really thankful Dr. Taufik sir for your valuable presence in this ATAL FDP, and there are so many participants as across the India, and so they were asked the good questions also, and I think it's enlightened their
Sir,
knowledge in the
खलक्कर सर, डॉक्टर
yes.
पी विघ्नेश कुछ बोलना चाहते हैं. वन ऑफ द
Okay.
पार्टिसिपेंट, विघ्नेश, you can just tell about your question in just short, basically 1 or 2 minutes. Dr. P. Vignesh.
Yes, sir. Am I audible, sir? Am I audible?
Yes,
Yeah.
yes, you are audible.
Yes, Professor, this is actually a very nice session. But actually, my question is, so we are working on high temperature polymers like PEK. So, what sort of parameters we can follow for the precision printing in those materials? Because we are looking for high temperature applications.
Okay. So which 3D printing technology you are utilizing, sir? Could you please tell me?
It's a
Sorry,
fuse
I not
filament.
got it.
It's a fuse filament modeling technology only we are following.
So
But
you are going to.
yeah.
Sorry, sir. I got one phone. That why I'm not able to hear your voice. Sorry. Could you please repeat your question?
Yes, sir.
Sorry.
Actually, we are actually working on high temperature peak based printing.
Okay.
Basically, peak is a high temperature polymer material, and we are following the filament fused filament methods for fabrication for fabricating that sort of materials. But we are facing the quality issues there. So, how to rework on that, or how to get rid of those?
Okay.
What do you call quality?
Okay. Got it. Your problem, sir. So sir, whenever we are going for the high temperature polymer printing, na,
Yeah.
so some important point you need to consider. First one is that you should take the proper tool path planning, because
Okay.
whenever the proper tool path planning is not there, means, see, listen sir, there are different tool path planning. For example, zigzag, okay,
Okay.
we have the fractal based tool path, okay.
Okay.
So one by one they are accumulating the layers.
Okay.
So what will happen na? At the end of the accumulation, some layers are going to solidify first and some layers are going to solidify after some time. So there is
Yes.
a delay time.
Okay.
Okay. So
Hmm.
due to the delay, some layers are going to uh, make proper binding and some are not. So they are making some curling in the printed
Okay.
part. Might be you have observed that curling also.
Yeah, that too we are observing. A
Yes.
bit difficult to print those
Yes, yes.
materials.
So what you need to do na, first of all, close your chamber, okay? The 3D
Okay.
printer, whatever you have, might be it is possible that is an open chamber 3D printer. So plus first close it, then provide one or two heater for the
Okay.
environmental heating. So it can maintain the temperature of environment up to some level, so the equilibrium will maintain for the
Okay.
for particular time period. So first calculate the delay time of your part, okay, means 2 points, whatever the maximum point, what is the delay time is coming. Then in between, if you are going to provide the proper heating, then it will be going to make your part in a proper uh, accuracy. Otherwise, what you can do, if it is not possible by yourself, then you can control the inclination also. In which inclination you are printing, sir? Horizontal, vertical, which type of
Actually,
part it is?
yeah, it's actually we are making for the high temperature application. As far as
Hello.
we are in the stage, early
हाँ
stage,
आ
we
रहे
are
हैं
just
थोड़ा
printing
सा
tensile specific. Yeah.
actually some call is coming from
Okay.
my
Okay.
home.
So
Sorry, sir.
initially, yeah. Oh, sorry, no issues.
So
Initially, we are
so
yeah. Initially, we are actually printing our tensile specimens. So in a raster angle of 90 degrees and 0 degrees, we are trying so far. So in this printing itself, we are facing these issues.
So 90 degree and 0 degree raster angles na. So what
Yes,
you
yes.
can do na sir, it is a bit uh, so what you can do, you can make it in somewhat 1 degree or 2 degree inclination, you can give it, sir. So
Okay.
whatever curling effect is there na, that will
Okay.
going to reduce or eliminate if you are going to
Okay.
provide 1 or 2 degree inclination. Got it, sir?
Yes, got it, sir. Thank
Because
you.
what will going to happen na, your part is going to break into the slices. So
Okay.
instead of making whole part, this type of part, you are
Okay.
going to make small patches.
Okay.
So delay time is automatically going to reduce.
Okay. Okay. Okay.
Got it, sir?
Yes, 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 sir. I can
Okay.
clearly understand. Thank you.
Okay.
Thank you.
Thank you, sir. Okay.
Yeah, okay.
Anyone else, sir? Any further question?
I think there are no further questions. You are getting a
Yes.
comments for
Yes. Yes.
very nice, good sessions and all.
Yeah. Yeah.
Yeah, I think. Okay.
Okay.
Uh, so yeah, Dr. Rachel SRA. So Taufik sir, we are getting as you might have seen this as regarding your session. So it was really informative. In the conclusion, I am again very much thankful to Dr. Mohammad Taufik for sparing his valuable time as well as sparing a very good productive information to all the viewers as a faculty, as they might doing some research in their labs and other things where really will be helpful for them. So I declared that today's day session is over. And
Yes. Yes.
dear all participants, tomorrow also kindly you join prior 10 minutes before the sessions, as according to schedule So tomorrow we will you will having a session of Mr. Piyush Uke. Okay, he is the founder of New Osa Medi Equipped Private Limited Nagpur. He is also the student of Triple ITDM Jabalpur, and then now he has started his own startup and working in the actual manufacturing of biomedical implants by 3D printing. So definitely that session will be very much helpful. And
Yeah.
the second session will be followed by Dr. Narendra Kumar. He is from NIT Jalandhar, Dr. Babasaheb Ambedkar National Institute of Technology Jalandhar. He will be also sharing his valuable findings and research of over the 3D printing. So I think today's session is over. Okay, thank you, Taufik sir. Thank you.
Yeah. Tomorrow's session
Yeah,
is at 6 p.m. basically.
6 p.m. Yeah.
Thank you, sir,
Yes.
for having me here
Thank
and
you.
giving
Thank
me
you. And
opportunity
the
to
link
talk
is
in
same.
your.
All the
Oh, sorry.
participants. Yeah, all
Sir,
the
the link
participants.
will be
Link is
different,
same.
sir.
Yes. Yeah.
No, link might be different, sir. Okay. So we'll share it on
Okay, sir.
WhatsApp group. Yeah.
Okay, sir.
Thank
Thank you,
you,
sir.
Taufik sir.
Okay.
Thank you,
Thank
sir,
you.
for having
Thank
me
you.
here, sir, and giving
Yeah.
opportunity to
Thank,
talk in
thank
such
you.
type of great FDPs. Thank you, sir.
बिल्कुल
Thank
we
you.
expect you
Thank you, sir.
physically with some another यानी कोई और ये रहेगा तो आप physically भी आइए.
जी जी सर, जी
Last year
जरूर सर.
मैं गया था सर MNIT भोपाल.
जी
He
जी
caught me
सर,
as a resource and all. So
जी सर, आपका सेशन बहुत अच्छा था सर.
चलो, thank you.
थैंक्स. ओके सर, थैंक यू.